This is the most precise and most accurate wall clock you can get. The time is synchronized to the GPS satellites, and the display reads out in units of 1/100th of a second. To be an ISO timestamp, there should be a capital T in the middle, but instead I thought it was more aesthetic to put the time zone there. This one is configured to switch between GMT and BST automatically. Other time zones are supported, but there's no interface to set it. You do need to use a programming cable. Time zones are a nightmare. It doesn't automatically work out the time zone based on your location, because there's not really a practical way of doing that without an internet connection. If we gave this clock Wi-Fi, it would be a different type of clock. I really like the fact that there is no interface, no controls, there's nothing to do. You just power it on and it will work out the time on its own and be exactly right. Of course, it will only be exactly right if it has a GPS fix, and indoors, depending on the building you're in, GPS reception isn't great. So if the colons stop flashing, that means that it doesn't have a fix. There's also an LED on the back which should be flashing once per second, and in this case the module has its own LED too. Without a fix, the time will drift. I've added space for a quartz crystal on the back to try and compensate for that, but to be honest, if the GPS doesn't have reception, it's best to try and arrange things so that it does. I've tried extending the antenna on its own without much success, but an easy thing to do is, instead of soldering the module directly to the PCB, you can extend the header and have a wire going to the GPS module, which can be on a windowsill or something. The display brightness is also automatic. This is done purely in analog, and at its dimmest it won't illuminate a pitch black room. I wanted to make sure that it's not annoying to leave the clock turned on all the time. There are a lot more technical details I'm skipping over, but one thing I wanted to point out is that the interpolation to get these centiseconds to tick correctly is far from trivial. We get a PPS signal from the module that indicates the start of a second, that is, the display should read 0 right now. Then we have to count up to the next second, and if we're counting just a little bit too fast or a little bit too slow, it needs to adjust. You can't just wait at 99 for the next pulse, because if there isn't a fix, that pulse won't be there. Coupling that with the fact that the UART data from the module that says what the time is arrives a few hundred milliseconds out of sync with the PPS signal, and the logic is not trivial at all. This is clearly ticking too fast for a human eye to see, but to prove that the precision is not just a gimmick, I invested in a 1000 frames per second camera so that we can see what's really going on. So here we are at 1000 frames per second, and this first shot is showing the synchronization between the GPS module and the display. I've stuck a mirror behind the clock so that we can see both the front and back at the same time. The display matrix has a refresh rate of about 2 or 3 milliseconds, which is why it appears to be flickering. But what we're looking for is the centiseconds to roll over exactly in step with the PPS LED. And there we go. I'll show it again with the lights off so that it's easier to see. Also, notice that the PPS signal lasts for exactly 0.1 of a second. Perfect. Here we have two clocks, and I find this quite satisfying. There's no communication between the clocks, they've both independently found the GPS signal and set their displays to be identical. One frame of video footage is 1 millisecond. There is some jitter. You can sometimes catch the odd frame where one has updated slightly out of step with the other. I think this is because the serial comms to the display driver takes a variable amount of time, in the worst case as much as 300 microseconds. That's 0.3 milliseconds. But given that our display is reading out to the nearest 10 milliseconds, I feel confident saying that these two clocks agree exactly. Of course, there could be a systematic error in the design and behaviour of the GPS module, so let's check that against some other time sources. This is a website called time.is, which does a browser-based synchronization and compensation for network delay. I wouldn't be surprised if the time server it's syncing to is also listening to GPS. In this instance, the laptop screen started to update 26 milliseconds after the precision clock, so that is within the 28 millisecond tolerance that time.is gave for its synchronization, but also the LVDS display driver has an inherent lag to it, which I don't really have a way of measuring, but it's probably around 10 or 20 milliseconds. The display is doing a progressive update. It's pretty cool that you can see the pixel response time. The 60Hz refresh rate means about 16 milliseconds between frames. If I hadn't set the backlight to full brightness, right now we'd only be able to see a seizure-inducing strobe light. PWM backlights tend to run at a few hundred hertz. Finally, let's take a look at a commercial radio-controlled clock. This is listening to the 60 kHz AM broadcast, but the clock doesn't expose any information about when it last synchronized or to what tolerance. Interestingly, in this footage, the radio-controlled clock has updated almost 100 milliseconds before the GPS clock. Now, I'm about 300 miles from Anthorn, which implies a speed of light delay of about 1.6 milliseconds, which is clearly being drowned out by whatever else is going on here. I've measured this a few times, and it's consistently about 100 milliseconds fast. By suspicious coincidence, the bit period of the 60 kHz signal is exactly 100 milliseconds, which suggests to me that there is a flaw in the implementation here, which is making this radio-controlled clock less accurate than it should be. If you would like to own a clock like this, I have made the software and hardware designs open source, but also I am selling it as a kit. So if you're interested in that, take a look in the description. If you're wondering how difficult it is to assemble that kit, then continue watching, because the rest of this video will now be a tutorial on how to assemble it. Well, it's both a video tutorial and an artistic endeavour, because let's be honest, is there anything more beautiful than assembling a precision clock?